So for our next example, we're going to take a look at sine of negative 75 degrees. Again, negative 75 degrees is not on our unit circle. The first thing I'm going to want to do is I'm going to want to rewrite this. Friendly reminder that sine is odd, so I can pull that negative to the front. So I have negative sine of 75 degrees. And that makes sense, right? Because negative 75 degrees is in quadrant 4. Y is negative, our sine is negative in quadrant 4. I can then rewrite this as negative sine of 150 degrees over 2 and use this equation right here to solve. So I have negative square root of 1 minus cosine alpha over 2. Well, my alpha is 150 degrees. We learned that the cosine of 150 degrees is negative square root of 3 over 2. So now I have negative 1 minus a negative square root of 3 over 2. That becomes a positive square root of 3 over 2, all over 2. We're going to add my numerator, so I have 2 plus the square root of 3 over 2 divided by 2. I have the square root of 2 plus the square root of 3 over 4, but it's negative. Don't forget the negative. And then we take the square root of our numerator and our denominator. So I have negative square root of 2 plus the square root of 3, all that's under the radical, divided by 2, because the square root of 4 is 2. Next, we're going to find some more exact values using the half angle formulas. But this time, I'm not told what my alpha is, what my angle is, and that's totally okay. I am given that the cosine of alpha is negative 2 over 3. And we are in quadrant. We're in quadrant 2. Nope. We're in quadrant. Alpha right now is in quadrant 3. But what quadrant will we be in when I divide alpha by 2? So let's go ahead and take pi divided by 2. It's less than alpha divided by 2, which is less than 3 pi divided by 4. Now, now I'm in quadrant. Hi, Bobby. How are you doing? Now I'm in quadrant 4. And so being in quadrant 4, hi, Kitty, tells me a few things. So in quadrant 4, sine is negative. Cosine is positive. I'm not in quadrant 4, I'm in quadrant 2. Bobby, you distracted me. So now I'm in quadrant 2, which is where sine is positive. Cosine is negative. And therefore tangent is also negative because we're in quadrant 2. I'm then just going to substitute in my value for cosine of alpha. Someday I will get all these equations to transfer over. So to figure out sine of alpha over 2, we're going to substitute into this equation. So I'll do that first in green. So if I have sine of alpha over 2, that equals 1 minus cosine of alpha, which is negative 2/3. Oh my gosh, you guys, this cat is trying to lay on my iPad trying to do math here. Okay, so over 2, that gives me 1 minus 2/3. That becomes a positive. So I get 5/3 over 2. Still all under the radical, still positive. So that gives me the square root of 5 over 6, which becomes the square root of 5 over the square root of 6. But we don't like radicals in the denominator. No, no, no. So I'm going to take the numerator and the denominator by the square root of 6. So I get the square root of 30 over 6. So that's how I'd figure out sine of alpha. I didn't have to figure out anything. I didn't have to figure out what sine of alpha was to figure out sine of alpha over 2, all because everything's beautifully defined with cosine. And remember, I'm in quadrant 2. That determines the whether the trig function is positive or negative. All right, let's go ahead and orange. I'm going to solve cosine of alpha over 2. Well, I know it's negative. I'm going to take square root of 1 plus negative 2/3 over 2. That becomes the square root of the negative square root of 1 plus 2/3 minus 2/3. That becomes a 1/3 divided by 2, which gives me the square root of 1/6, which gives me 1 over the square root of 6, but it's negative. Don't forget it's negative. So I get negative square root of 6 over 6. Last but not least, let's solve the tangent. Probably should make us some more room. We never have enough room. So tangent of alpha over 2, because we're in quadrant 2, is going to be negative. And tangent of alpha over 2 equals 1 minus cosine of alpha over 1 plus cosine of alpha. So I have the square root of 1 minus a negative 2/3 over 1 plus a negative 2/3. So I get the square root of 5/3 divided by 1/3. And it's negative. Don't forget it's negative. That means the square root of 5 over 1, which is just the square root of 5. The negative square root of 5 is our final answer for tangent of alpha over 2. Last thing I want to introduce, I believe this is the final slide, is that tangent of alpha over 2 can be expressed in another way. It can be expressed as 1 minus cosine of alpha over sine of alpha, or sine of alpha over 1 plus cosine of alpha. So there's two other ways that we can express the tangent of alpha over 2.